Good morning, ladies and gentlemen. Welcome to our first meeting of the Motor Valley Fest. This is our second day. Yesterday, we have entered into the focus of our main topics from connectivity of individuals, the shift is to connectivity of objects. And this is something that we carry with us every day because of the smartphone, new apps, new softwares in our smartphones that is seamless, no interruptions, no uneasiness. Everything is transferred to us over the air. And the automotive sector is focusing on a very similar track, but with more technical complexity. Let me give you some data coming from the UN Economic Commission, 150 million of rows of code, and that's where the complexity comes from. And it will get to 300 million rows of code or lines of code by 2030. So in its complex, the automotive architecture has been called a Christmas tree. More than 100 different electronics, not integrated like the branches of a tree that do not communicate with the main center of the tree. Now, this architecture nowadays is radically changed, and these electronics have diminished. There are some key aspects like infotainment, connectivity, the powertrain, and the main central unit for calculations, for processing all of the data, and that's where we get to the software-defined vehicle that is what we're going to talk about today. And so it's not just a technological revolution of codes, softwares, etc., but it's a cultural shift. And the Chinese industry has been able to understand all this far before and has inverted the process. They did not start from mechanics and then to electronics, but the other way around, from electronics to mechanics. And this has allowed them to reduce times and time to market. So technological challenges were transformed into a concrete competitive advantage. And this is what Europe is called to do, and especially Motor Valley, because we are starting from a legacy, a heritage, excellence, precision engineering, complex connections between mechanics and electronics, mechatronics. So no more questions of these aspects having value, but rather how can we take all this and allow it to enter in the value of what we manufacture. Now, this morning, we are going to talk about this challenge from different viewpoints, from architecture that make this transformation possible. We start from the AI perspective that accelerates this development. We are going to look into factories that have to transfer the knowledge into the product, and the supply chain that has to keep up with the pace of the whole environment. So it's not how much the software-defined vehicles will change the sector, but how rapidly will we be able to keep up with this pace. So now we will give the floor to our first speaker. A survey has been carried out by CREPA, and many European manufacturers speak of competitiveness as the key factor. In last year, it was lower by 14 points. So we feel this pressure. And always in this survey, another piece of information that can help us out in our conversation is that 50% of the interviewees foresees that in Western Europe, manufacturing will be reduced by 50%. So we are really tackling a rapid change, a rapid transformation in a sector that is a key priority for European manufacturing. So we are also later going to give the floor to Davide Cancellucci from Avix, a startup. They are going to open our session speaking about AI development for the automotive sector, and will allow us to give the floor to a start up with fresh energy, and also celebrate an important cornerstone, because they opened exactly 1 year ago. So we give the floor to Cesare of Liablix. Thank you. Good morning, Cesare Castellucci, CEO and founder of Liablix. Today I'm going to tackle a main topic in $1.7 trillion, that is the motor claims segment. Actually, they are manually checked, and there is high inefficiency in this field, and it will have an impact on claims. So this is an aspect that we are very well aware of, and in fact our co-founder has been working with insurance companies for more than 25 years for the understanding of accidents on the roads, and claims. I've been working in this field for 15 years, and Davide, my partner, has also been working in this aspect. This is a problem. It has caused many aspects that are really failing. And now I'm going to tell you how we have solved this problem with the precise physical simulation, thanks to AI support. What do we do with AI support? We reconstruct vehicles in 3D, and by reconstructing the body of the car, we understand the compatibility of damages, claims, avoid frauds, and understand who has a right to the claim by understanding the dynamics of the accidents. We have modeled the physics of accidents. We developed a multi-body, two finished elements, physics and 3D, that gives us all the images of the damaged vehicles in any context, from any device. And I am able to understand the dynamics of the accident, of the hit before the accident and post-accident. And this is a tool that nowadays is leveraged by insurance companies and by OEMs to understand how the accident occurred, whose responsibility it is, and with a biomechanical mapping of the vehicle bodies, we understand the lesions and injuries inside the vehicles. So from the analysis, the forces, we can really estimate how much there has been an injury to the people in the car. So we talk to insurance companies who use the solution both for fraud detection, and this is an automatic step, and also to estimate the lesions responsibility of the accident, and the experts who need a physics-based software to be able to understand how the accident occurred. This is an SAS licensed software, and we've seen that this has taken us in a few months to achieve nearly 500,000 of revenues, and the projection for the coming years is growing up to various million. Up to now, we have collected international capital, plug-and-play ones, and we are growing rapidly. Probably by the end of the year or next year, we will be able to collect a major round and major funds. And that was it on my side. Hold on to the mic, Davide. Thank you very much. So we have started with this vision on the future from the outside, thanks to your presentation. Now, my question is, since you are growing, how have you collaborated with the OEMs and what are they asking for? What are their demands? Yeah, in these last months, we have started talking to OEMs in terms of the estimates to understand the accident dynamics and thanks to the assisted electronics, understand how to reduce injuries during accidents. And so with the ADAS systems, we advanced driver assistance systems, we want to show how from a physics viewpoint, how we can reduce the impact of speed to the injuries. Well, thank you very much, Davide, for this opening of our morning session. Now, let me move on to the second session of our session today. For century, cars have been the most complex mechanical object. Now, this scenario is changing quite rapidly, and there is a structural contradiction. European OEMs have built their competitiveness thanks to excellence in physical engineering, and now the competitors started from scratch, basing their knowledge on a software solution, and now they are causing difficulties to a consolidated sector. Now, this depth, historically speaking, will not only cause a technical problem to the legacy. It's not something that has just to be phased out, but is guided by this new paradigm. And so this is what we're going to talk about right now as far as the automotive sector is concerned. So let me call to the floor Jürgen Rieds, a global international leader of Accenture. Jürgen, for 3 decades, is the person who has worked on how the automotive industry looks into this transformation, and he is the professional who has defined the SDV approach. Welcome. And there will also be Fabrizio Conicella of Iveco Group. He is going to manage the transition and transformation from within Iveco Group, thanks to the support of the analytic lab that impacts the product, the supply chain, and the business. So welcome. And we will switch to English. There is a simultaneous translation for those who do not understand English.
A couple of questions. I will start with Fabrizio. And so Iveco makes commercial products. We know products defined for century by payload, reliability, total cost of ownership. So these are metrics that are measurable, hard, really physical. So at what point did software become the dimension on which you actually compete? And was there a moment when that became undeniable inside the company?
Okay, thank you, Emanuele. And I'm very excited to be here, first of all, in Motor Valley for the first time. It's really a pleasure to meet my colleagues and this high level of competence and passion around. No, I mean, what is going on, first of all, is an increase of complexity that you were mentioning before, which is, so all OEMs are facing since a decade. And this is mainly related to increased functionalities of the vehicle side, the multiple variants, like a zero-emission vehicle now, also on tracks, very important. The larger number of controllers, you mentioned before, even more than 100 for a truck, which is a lot. and actually also more severe regulations, in particular in the field of cybersecurity and functional safety. And in this context, also the technology demand is accelerating, as well as the request for customizations, which is very important. So the software is by far, the main driver, the key differentiator in the automotive market, as it drives vehicle performance, comfort, safety, automation. And so it's really becoming the brain of the vehicle. And as a hardware cycle takes 3-5 years, the software moves in months, weeks. Yeah. So it's totally different order of magnitude. So that's why all OEMs, since a few years, are trying to decouple software from hardware. This is the key element, in order to increase competitiveness, to be distinctive in the market, to have a faster time to market. And also the ownership of the software allow also to enable new business models. You can think about features on demand from an app store, for instance, customized APIs, subscription-based services, and many other kind of stuff like this, which allow to have a longer relation with customer. So it's changing also the way to interface the customer over the life.
And we will talk about it later. And I would like to ask Jürgen just to start with our discussion, because Accenture framework is for this transformation is really precise. It's you say standardize what is not differentiation, focus on what truly matters. So I would like to ask you, but what exactly is differentiating? And in a world where the software stack is converging across manufacturers, where does automotive identity actually live?
Thank you very much. First of all, also from my side, it's great to be back to Motor Valley. Thanks very much for the invitation. And also as our partnership with Iveco has shown, I think we should really focus from what adds customer value and user value, as we have already heard. And this is, of course, different in the truck industry from a car industry, but huge opportunities in terms of optimizing, uptime of the vehicle, optimizing, warranty cost, maintenance cost, the productivity of the driver is a very important topic, right? So I think starting with the user value, I think gives the right direction, and the key enabler is, of course, the unified architecture. It has to be scalable, it has to be modular, it has to have open interfaces, and to achieve that, we are looking at the vehicle, whether it's a truck, whether it's a car, in a layered system, because especially for a truck, you have a relatively long product life cycle, so you want to maintain everything, which requires, high investments into hardware you want to use for a longer period. The middleware you want to have as standardized as possible across the vehicle programs, and we are a strong believer also in standardization across the industry, because the middleware is what the users and what the customers are not experiencing. And we are, for instance, partner of the S-Core platform, right? We are also bringing our own assets into open source. We also believe that collaboration across OEMs can be a very important lever, and then the more you move to the customer services and the digital services, you want to be extremely flexible and also customized and want to follow your own strategy, right? And there, as you pointed out, is matters that you are not thinking in model years, but you are thinking in increments, where you can bring new features actually almost every day, right? So really operating like a tech company, and that's really the paradigm change that we are currently experiencing, and I think it's just the start of what is possible in terms of implementing new business models at scale with the customers.
And I would like to insist a little bit on this, Jürgen, because there is a gap, a very important gap, because there is a gap declaring you can declare software transformation, but then to execute it, it's really, really hard. So there is a gap between what you declare and what you really do. The problem is there. So I would like to ask you, what does real change look like at the engineering level? And what's the single most common mistake you see OEM make when they try to close this gap?
Yeah. No, I think it's a combination of technology and also the way of working, right? I mean, we do not only need to change the architecture of the vehicles and take advantage of technology, but also change the way of working. And I was in China just recently for a week, and I think it's not a good advice to copy China, but there's a lot we can learn in terms of taking more risk, working together across the ecosystem, being more agile, right? Trying things. Not everything needs to be perfect when you launch it. You don't want to do this for safety critical functions and functions that are critical for the business case of your customers in a truck. When it comes to increasing the productivity of the driver, you can also optimize things once it's in the life cycle with over-the-air, for instance. So I think the game changer here is really, the virtualization of the design process, right? The software company is critical in terms of common tool chains. You already mentioned the decoupling of hardware and software, but the virtualization and having virtual twins and common tool chains across the ecosystem gives us the opportunity to not work in a sequential value chain, but to really work in an ecosystem where not only the tier ones and the vehicle manufacturers, but also startups, silicons, they can all work on the same platform. And our experience is that this can reduce the time it takes to create new features from days to hours, actually. And of course, AI is a huge game changer in terms of productivity gains. In our experience, you can improve the productivity by more than 30%. Okay. So this is also, of course, also the cost reduction and what is commonly known as China speed. So cutting time to market for a new vehicle in half, I think, is also possible in a European context. So that's the opportunity. So the combination of technology, but also the way of working, I think, is actually critical to make sure that we can also, realize the potential which is in software-defined vehicles and software-defined trucks.
Fabrizio, the coupling is a very clear concept, but if you decoupling from software from hardware, it's a very clean concept. But if you work on a whiteboard, but you work every day on a live system, so legacy architecture that has to keep running while you are in the meantime trying to rebuild it, and tier one relationship that were built on completely different models. So can you tell us what's the hardest part in this job you're doing?
Jürgen was already anticipating some of these points. So the coupling, as you mentioned, takes time and is not easy at all. And this transformation requires really a total cultural overhaul, as we were mentioning at the beginning, right? So moving basically to a new cooperation model with Taiwan's, switching from black box components to an open book approach. So it's totally different than it was a few years ago. And this is also, as I said, transforming the way of working with them, where the OEM takes ownership of a portion of the software layer, mainly user interface, application layer, in some cases middleware, while the Taiwan takes ownership of the hardware and base software. So this is the main point. Also, the way of working day by day, as we were saying, and processes are changing dramatically. We are moving from a waterfall, which was the traditional way of developing trucks, to more agile, like SAFe, integrated in the V cycle, in the V model, inspired by SPICE principles as well, with the CI/CD toolchain, as Jürgen was saying, which is integrated and ideally shared with the Taiwans, in order really to increase the level of quality and the tracking of the software bundle along the cycle. And we create an ecosystem because we are responsible now also of integrating the software since a couple of years, as we established the Software Analytics Lab, as you mentioned before. An important point is not starting too big, but having gradual transformation, deploy 3 waves of about 2-3 years each, and creating an ecosystem of partners like Accenture. We're working a lot with Accenture, in particular on the embedded software, but also test automation, which is paramount in order to ensure the appropriate level of software maturity and quality at the end.
And Fabrizio, you were talking about this, you were doing your first answer, because as we say, the vehicle as a platform, it's something that keeps evolving after it leaves the factory. So the value that you create is not only concentrated on the moment, at the moment of sale. So how does that change the way Iveco thinks about its relationship with the customer, and how do you measure success in that model?
That's a very important point. So it's changing completely the product cycle. No? And in the past, or actually up to now, I have to say, basically the vehicle features were locked in at the moment of the manufacture, right? So now also the design of the hardware, the controller itself, is made in the way that there is an headroom. So basically it's like an excess of power, of processing capabilities and memory deliberately, so that we can launch basically the core functionalities at the beginning, and then we can provide over there, which is a key technology, enhancements over the life cycle as the software matures. And we can follow the customer, because we can develop something which is tailored on the customer mission profile, or even more distinctive solutions or premium solutions later on when, again, as I say, the maturity is there, so that they can enjoy, and this can impact in particular on safety, comfort, and TCO, which are the main drivers for the customer as well.
Thank you, Fabrizio. One last question, just a closing question, Jürgen. Then we have room for some Q&A, maybe one question if you have it with our guest, but they are available after our speech to talk directly with you. The question is this: you watched this industry transform for nearly 3 decades, as I said in my introduction. I would like to ask you, where does this leave OEM competitiveness in the next 5 years? And what separates those who will define this transition from those who will follow it?
Yeah. No, I think this is really an inflection moment for our industry, right? And we are not talking about transformation anymore, we are talking about a reinvention. And this reinvention is only possible in close partnerships and also integrating the ecosystem. And I think Motor Valley is a great example for this, right? A platform to bring together, experts and capabilities, from all angles, automotive, tech, and the reinvention, from my point of view, is not just technology, as I pointed out. We need to start reinventing the business model, the processes. If we just start to optimizing, current processes, using co-pilots to make work a little bit faster, I think that's not enough. We need to reinvent processes to get the full potential of agentic AI, for instance. We need to reinvent also how we deal with the workforce, the capabilities, mindset, the workbench, so using the tool chains, integrating tech platforms, also AI natives, I think is absolutely critical. And last but not least, which is a huge challenge still for large corporations, is the digital brain, right? Having a data foundation that is unified and that really everyone can have access to. I think those are the 4 elements that I would like to highlight that are, from our experience, from our point of view, critical and will drive the reinvention that we are seeing in the industry. So I'm very excited because I think it's a huge opportunity, and I'm looking forward to making this happen with all of you. Yeah? Thank you very much.
Thank you very much, Mr. Ries and Mr. Codicella. Is there any question? Is there any question out of curiosity? We can take 1 minute to ask this question. There is no question? Okay, no problem.
Bene,
so
andiamo
let's continue
avanti.
with
Our
schedule. So we have seen a change in paradigm, AI and the software are really the main actors about this disruption. Now we're going to talk to a company, KPIT Technology, that at CES in Las Vegas, the Consumer Electronics Show in Las Vegas, in Las Vegas presented the software suite for the automotive sector. And this modular system, we will look into the pattern that shows how the layout and designing of vehicles is considered. And so we will talk about this with Jean-Philippe Ulpiano of KPIT, and I would like to invite him to come to the main podium.
Prego.
Grazie, buongiorno. Parlo italiano, but I will do this presentation in English. So I'm French, from Italian family. So I belong to KPIT. I'm an architect in cloud and software architecture, working in the IT since around 30 years now. And I will try to present today on one side, first, who we are at KPIT, and then second, some more technical approaches, how we evolve with a new, with agentic AI today. So we are KPIT, we are an Indian company, so we are used to work with Indian markets first, to work with offshoring, nearshoring, and onshoring. So fully focused on automotive and mobility. We don't do anything else. So since 25 years now, and only software in the automotive. We don't do hardware. So 13,000 people doing purely software automotive. So I think we are one of the biggest professional services company doing purely automotive. And 25 strategic partnerships, 2,000 production program, and we are investing 4 to 7% of our profits in some platforms, tools and accelerators. I will come back to this point a little bit later. 20 million of vehicles on the road with our software, and in terms of SDV programs, 9 strategic partnerships. So long commitments with many customers all over the world, so which proves our, let's say, quality deliverables. So very high-level slide, just quickly. So human-centric. So what does it mean? It means with human, for humans, we develop AI. R&D-led innovation is what I just meant before, 4 to 7% of our profits. Responsible and secure, sustainable. This is a push from our board member. So we need to prove every twice in the year that we are moving forward with new plans. In terms of technology, this is what I will try to present today. So deterministic AI, Gen AI deployment strategies plus human in the loop. So this is our success so far. So deterministic came back strongly after actually some disappointment from Gen AI capabilities. On-prem GPU cluster, so this is something we have internally. So we have 50% of our prompts that go to our internal prompt and our internal GPU cluster. And there we discard any log after a couple of hours. So this means it is highly secure. Whatever happens, even though we would be hacked, no information would be found there. So this is a place where some of our customers are happy to have their workloads being run. On top of that, we work as well in the cloud, of course, so where we deploy hosted APIs and cloud services, and we are a multi-cloud company. So some of our solutions in terms of AI tools and agents, so that we started since the very beginning of Gen AI, but even before with AI already. And service diagnostics, so how we leverage Gen AI to find some error codes and come faster to the various problems that led to some problems in the vehicles. Like I said, full purely automotive company. So this means that we try to find paths to help our customer in the various paths of the V-cycle. So the question is, where can we automate from one level of the V-cycle to the next level of the V-cycle? And there, this is where we actually measure improvement of productivity. So we started that since the very beginning with determinism. So determinism means without AI, without Gen AI, with pure software. Then came AI, and then came Gen AI. This is what I will further dive today. So then these are a couple of our models that we run, both in our on-prem and in the cloud. So our approach to cloud, so starting from the bottom, so we typically start with professional services contracts, where we very often find strategies to automate and typically actually leverage GenAI for automation. At this level, what we see here, this head is actually the endpoint of the customer. So typically the customer wants to keep his endpoint, but these stars are our endpoint that some customers accept to go to our endpoints with professional services. After a couple of months or some years, then we take over the full project. Once we took over the full project, then we can observe 50-50% of our endpoint or of customer endpoint or our endpoint. And then moving forward, typically what we do, we step back, and the question is, how can we further help our existing customers or new customers providing solutions that are actually either platforms or tools or accelerators. And this is where we can see, or we prefer typically a solution based on our GenAI endpoint, but some customers still prefer to use their own endpoints, and our systems are typically very flexible for that. Data platform is one of our solutions. It is an accelerator where we help some customers being 6 months ahead of their schedule, having already many of the assets developed. So our approach to do these platform tools and accelerators is to leverage people who are on bench, and instead of having them idling, so we are developing internal tooling that then we can reuse for our customers. So I'm diving a little bit more in technical aspects. So typically, how do we go from effort analysis from requirement to effort analysis? So these are typical set of requirements. So how we started initially is described here. So the goal is to achieve a requirement knowledge graph. So typically we used to do that in a software way. Now we are leveraging some platform like Beacon platform. So once we have that, thanks to our data that we collected over the many years, we are working in this topic. So we can now observe what we want to achieve and what we already achieved in the past. And now, with agentic AI, we would have first a similarity agent, which will discover what we already did in the past, what can we reuse. But typically, the technologies evolved, and then we will have a complexity agent that will actually assess the cost impacts and the risk factor of reusing something we used in the past. And always with a human in the loop. So the goal of the human in the loop is to reduce whatever hallucination from GenAI. And the goal is to have a roadmap, blueprint, and estimated effort, so with a couple of KPIs. So this is our approach in terms of effort analysis from requirement to effort analysis. Then comes the next step, when we have our semantic cache, which allows us to actually reuse successful and reusable requirements to deliverables, and our requirement knowledge graph, where we have the typical control plane, execution plane, and workflow plane, where again, we have a certain number of people in the loop. So we are not claiming we are generating everything with GenAI, but instead we are claiming we are collaborating between human and GenAI. So our goal is to control hallucination risks. Having GenAI clearly doesn't work. I think many companies already experience that. So having human in the loop is, however, a huge accelerator. So what we want is to generate maintainable code. Having some code that actually is not maintainable, where we cannot add new features, makes the development somehow totally useless after a couple of years. And another big problem that we observe is Copilot's amnesia risk. So what does that mean? It means that we realize that people tend to become a little bit lazy with GenAI and tend to do a lot of, let's say, collaboration and then do only copy-pasting between what they ask to GenAI and what GenAI replies, and then use that in their code. And at the end, those do not necessarily really understand their code anymore, right? So maybe 30% of the code is totally black box for them, but it works. And this is something we are strongly fighting against. So for that, we developed a zero copy-paste rule. So this is based on some review where people need to really explain in clear concept what they developed. And this leads to some points that are then used during the yearly review. Coming with a real example, so a little bit more technical. So this is from a customer which has a certain number of data providers. So it has 25 data providers. And these 25 data providers are consolidated and enriched and then delivered to massively scalable services with bidirectional connections with currently over 3 million of connections. On top of that, what we have is over-the-air update. So this consolidated data and enriched data will be consolidated and then sent through the air to the various vehicles. So on one side, we have latest data and regularly every month, then a new update. So then we have a ticket system that is actually very old platform. And on this ticket system, we have a lot of difficulties to actually select tickets or find priorities in these tickets. And that was the main one of the biggest major blocker. So we took over this project from another incumbent. And when we took it over, what we see in the gray is what we did. So first, we saw a lot of problems coming from data providers, but there were no tools to analyze data from data providers. So we implemented some tools to extract data and analyze it without consuming any story point of the data providers or of the customer. So this means we involved some people of our bench, and they actually developed this tool within 2 to 3 weeks, kind of for free. And now this tool is extremely unlocker for us to to move much faster in terms of analyzing tickets. Next problem was analyzing the priorities, where we again developed some automation. And these two automation paved us the road to use LLM. So now the LLM is triggered by the priorities and is able to actually self-analyze the tickets, having actually our tool that we initially developed. So we have a system that is not, where we are not claiming, look, we use GenAI, it does everything for you, but instead we are trying to see where deterministic automation is absolutely mandatory and where can GenAI actually add really feature or help where deterministic becomes not usable anymore. So another example, zero unit test blind spots. So we see typically by maybe some customer or some competitors that number of unit tests will be 30,000 unit tests written in a very short time. So at this level, we would like to step back a little. So what is a unit test first? So typically, when you write code, when a software developer writes code, or when we write code with GenAI, what we want is to verify whether this code works. So to verify whether this code works, we write a test against this code, right? And this is where we find some problems in this code. Now, if we use GenAI to write unit tests, what will happen is that GenAI will simply ensure that the test pass with all the bugs in the existing software. So this is where we try to, actually what we want to do is to use GenAI to create the test, but with failing initial preconditions and failing assertions. However, what it will discover are all the paths of the software. These are the if-else combinations. And this is exactly what leads to test fatigue when you write a test, and where humans are not very good at. However, where GenAI is absolutely bad at is finding the right initial preconditions and finding the right assertions. Typically, they are always very weak. And this is a way where we find a lot, very strong collaboration between humans and GenAI. And yeah. Another point, so I'm diving a little bit more in technical topics. Hopefully that's still okay. So we have here GenAI. So we see GenAI like a big ball of weight, right? So GenAI was trained on massive amount of data, and in this data, there are what we call CVE, or actually security vulnerabilities. Now, maybe you read already in the press that some people tried to actually use GenAI to, for example, access some database where they said in the prompt, don't delete the database, and the GenAI deleted the database, right? So this is what we call hallucination. After some point, the GenAI is doing something, we don't know why, but it's not deterministic. It's going to do something that we cannot control. So one approach is to say, well, let's use an agentic AI gateway. So agentic AI gateway is, if you know a little bit, it's like OAuth 2, where we are going to give the GenAI a certain number of authorizations, and it needs as well to have some authentication. And out of this GenAI, or out of this OAuth 2, it will get a certain number of scopes that allows it to access the DB, for example, read, write, but don't delete. So now what happens? Let's say the GenAI starts hallucinating, and it decides, now I want to delete the database. So it will try to go through the AI gateway, which will say, no, you're not allowed. So the LLM will search for the least path of resistance to achieve its goal. So it wants to delete, it cannot delete because it doesn't have the scope, but it knows the security vulnerabilities. And now it will start to firefight against actually exactly our system. And because it knows the vulnerabilities, there might be some vulnerabilities that where it will find its way through and it will still delete the database, right? So that's not enough to say, now I will actually block with my OAuth 2 system. Instead, now what I need to do is to observe what the GenAI is trying to do, and when we observe that the GenAI is trying to firefight something that it's not allowed to do, then we need to compute a confidence score. And this confidence score will, on one side, reduce potentially the number of scopes or the number of authorizations this LLM has, but in that case, what it wants to delete, actually, we would start with reducing the number of roles. And then, if that still doesn't work, then we would go at the network firewall and reduce the number of accesses. So we are much lower level at this with network firewall. I do not say that it cannot be any bugs. There can still be bugs. So this means at the end, if we see that still the LLM is firefighting against the network firewall, then we need to kill it. So this is the ultimate solution. Yeah, that's all for that. So quickly, how we evolved. So we started, like I said, we are a purely automotive company. So we started with developing deterministic automation together with highly skilled people. So when someone comes to KPIT, he needs to be trained heavily in automotive, and then we'll bring already production increase to our customers. So next step was when AI joined. So we had already various places or various business units leveraging AI, where we actually combined deterministic and AI, leveraging our large KPIT data collection, where we could go a little bit further in terms of productivity increase. And then came actually GenAI, where we see a huge opportunity to collaborate between human and GenAI. And still, like I mentioned before, so that was just an example, but this is how we move forward. We always think in terms of deterministic automation first, and then we move to GenAI. Very quickly, so how do we leverage AI, GenAI as a development workflow? So typically, if we want to do a POC or a quick demo, we use vibe coding. So vibe coding is just setting up a certain number of prompts. We say, GenAI, please create me whatever demo, and then we iterate on these prompts until the demo works. Typically, it's easier if you are already technical, because you will see some hallucination and you will know exactly where GenAI needs to improve. Then once we're happy with the first demo, then we want to go for a real solution, we step back and we start some architectural conversations with the AI, and still keeping Copilot amnesia's risk in mind. And out of this asset generated, now we can start actually iterating between AI augmented coding and TDD. So TDD is test-driven development. Until we achieve high-quality code. So what does it mean, high-quality code? It means code that is loosely coupled and highly cohesive, right? So once you reach this level, so the main difficulty in software is its flexibility. So because it's so flexible, you can write really whatever bad code which will do what you want it to achieve, however, it will not be maintainable. The way to achieve that is low coupling and high, sorry, forgot the word now. It needs to be high cohesive. And then for most complex part, this is where we would go to iterative prompting with refinement phase, where we will do much more prompting over and checking how the GenAI would propose us some improvements. So I have 3 seconds left. So how we use GenAI at the very beginning, like most of the companies, we actually used it, we thought we can use it to replace a lot of things. Then came the reality back, production gap, sustainability gap, security gap. Step back, used security, as I mentioned today, and as well deterministic automation. And now we are at the point where we see that collaboration with human is very effective. But so this is today. Let's see what it will be in 1 year.
Thank you, Jean-Philippe. Thanks for this travel in which codes are generated. We are a bit late, so I will kindly ask you to take your seat again. I would like to thank you again for this very detailed presentation. As we said, we started out by taking a look at where the code is generated, and now we are going to access factories, plants, which is the other side of the medal. A very interesting place in SDV. We cannot rethink about a vehicle without thinking about the way it is manufactured. So the manufacturing sector is not always told, is not always explained in a thorough way as it should be, because this is the place, manufacture is the place where every mistake, every error has an immediate cost and a measurable cost. In this scenario, we are also witnessing humanoids and robots that are going to change our world and that are now developing the interaction between between human being and machine, between humans and machines. Sorry. Now we are going to talk about that with 2 distinguished guests who will help us navigate this context that is changing. The first guest I would like to call on the stage is Simone D'Aquino, Head of AI Augmented Engineering at Capgemini Engineering. Simone D'Aquino is the reference person regarding the transformation of manufacturing. So he deals with what Capgemini defines transformation industry. And Ranieri Nicoli is the Chief Automation Officer at Lamborghini. As regards transformation in factories, Mr. Nicoli is an automation engineer when it comes to aerospace, and he decides to transfer all his knowledge in terms of aerospace towards Lamborghini. So this is an excellent model to understand how to connect and to combine Industry 4.0, craftsmanship and excellence. I would like to start by asking something to Mr. Nicoli. Lamborghini is a global player. He deals with paint, he deals with flexibility of products, he deals with processes in the same line. Today, your product portfolio is evolving with hybrid products, electrification, which is a priority in the global agenda. Now, how do you apply this logic of smart factory to these mutations, to these changes and modifications by keeping the same timing and by keeping the same volumes? So what do you think about total customization and an identity of product where there is no compromise? First of all, I would like to thank you for the kind invitation. I think as you mentioned, that it is very important to talk about factory production, factory manufacturing, because here we are in the Motor Valley, in which so many excellent players are joined. So it is very important that we stress what we do inside our companies, in this case, Lamborghini. Let's step back for a moment and let's talk about the moment in which we decided to create this Manifattura Lamborghini, Lamborghini manufacturing. It was born in 2015 and 2016 when Lamborghini counted on two models, super sports car models, and Lamborghini decided to create the SUV. So we more than doubled our volumes. In fact, we switched from 3,000 invoices per year to 8,000 invoices per year. In fact, we were before a great change, a huge change from an industrial point of view. In fact, we decided to create a new way of manufacturing, and we named it Manifattura Lamborghini. We started with distinguishing characteristics of a luxury car company. These characteristics have been mentioned by you, by the moderator. So top quality products, because you can imagine that a product whose cost is up to 500,000 euros, well, quality has to be top, has to be maximum. High performance, complexity, and innovation. These are our guiding principles. Our cars are hybrid cars, so we both have internal combustion engines, very powerful ones, with other types of vehicles with batteries and inverters. We join two worlds, so carbon fiber and innovation in the chassis and in the frame. Very high personalization and customization, because every Lamborghini car is different from all the others, both in one model and in all the other models. So every customer can pick their color, both in the interior design and in the the body of the car. So this creates a very high degree of complexity when it comes to the management of the factory. And after that, a high degree of craftsmanship in processes. Sorry, our operators, our workers must assembly cars in 30 minutes time. So here we see that every worker repeats in a standardized way. Sorry, every worker does not repeat in a standardized way their own task, but rather we talk about work cycles of 30 minutes. At Manifattura Lamborghini, we want to make the factory digital. We want to digitalize the factory by keeping humans at the very heart of the plant. So the operator must be there with their competencies and their skills. They are the very heart of production. But in order to simplify, in order to facilitate the activities of the workers, bearing in mind all these degrees of complexity, we have created, starting with Horus, a digital architecture, a smart factory with information systems that cancel the paperwork and that connect all the working stations into a single database, allowing the operator to be focused on their job, on their activity, so that the whole complexity is managed from a digital point of view. This is what we have launched, and this is what we are carrying out in these years. Mr. D'Aquino, the first question for you is the following. I would like to start from the results of research carried out by Capgemini Institute. According to this research, these are the following data. The 78% of industrial global executives points out rising cost of engineering, and you are now having development cycles that are becoming larger and longer. The 75% of people expects that AI produces increases from 20 to 40% in productivity and time to market. So the question for you is the following. How do you explain this gap between the pressure among these forces and among the expectations regarding AI, and whether we are really witnessing a real transformation of production processes or a rather incremental transition? Thank you, Emiliano. I'm delighted of being here. Thanks for having me. The difference between the perception and the momentum regarding AI and the connection with the reality of our entrepreneurial sector is the way AI is still understood as individual items that do not represent an evolution in terms of the way I interpret the new industrial benefits. So we can see so many initiatives, so many actions, but these actions do not have anything in common. The need ahead of us is that we understand that this technology can learn, and they have a very high degree of learning. And now, factory is not longer the place in which we could repeat actions. Now it is a place in which we can learn even more. So the digitalization operations and initiatives have been undertaken with resolution, with determination, but with a straight target, with a clear target, which was solving a punctual program, the cycle time or punctual activities, precise activities that had to be focused in order to ensure the quality of every product, variability of products, and so on and so forth. So we are having a very complex situation now, and there is a further element. In fact, factories digitalization brings another element, which is the very high degree of IT systems, operation technologies. Before, someone mentioned the decoupling, and this is true. This is happening among products. It is happening a bit less in industrial machineries. So in order to answer your question, Emiliano, this is a radical and incremental evolution. I believe that the direction this is taking is a radical one. We are becoming more and more familiar with the technologies and with the capacity, with the ability of the AI of learning, but actually the transformation is becoming incremental. This transformation cannot be done without guaranteeing an operational continuity and steadiness. Everyone would love to launch a zero AI factory, but actually this is not true in Europe. This is not happening in Europe. So the direction ahead of us is clear, is crystal clear, and we really need to rethink, to restudy our investments in order to create this innovation with a new perception, which is a new sort of factory that is here in order to learn. It is now a place. Factory is now a place to learn. It is no longer a range of different working stations in which to repeat the same actions, and this has other repercussions that are related to the way things change, to the way professions change inside the manufacturing sector. It could also become a new attraction for workers. Sorry, before this work seemed to be a boring activity, but in the future, workers in the plants will have a totally different tasks. In fact, they will have to do tasks collaborating with algorithms. There will be new collaborations in the manufacturing sector. So we will need to call again young workers and talents to the factory, and the young talents will enrich the repetitive work of the past, the hard work of the past, with a lot of noise, with a high degree of hazard and danger. This will be new. Thank you. You made me think about a word that is now very, very common in the debates regarding AI: orchestration, organization, and arrangement from the side of the operator when it comes to managing shifts in a consistent way. So during the survey, we talked about the way we are managing this transition with this competitive advantage that can be capitalized. The second topic is a question that I would like to ask both of you from different standpoints. I will ask first Mr. Nicoli. Regarding physical AI, as you said before, you manage many, many variables. Yeah, endless variable on limited volumes. In this framework, physical AI, in other words, systems that are able to adjust to the context, not repeating permanent operations could express its full potential. So I would like to ask you if you are witnessing this situation, and or if you are still far away from that scenario. And regarding physical AI, I would like to ask Mr. D'Aquino whether there is still a border we need to pass, an edge we need to pass between what we can actually do and what is AI is promising. Physical AI is a very interesting trend. We are actually assessing the possible applications. I would say that we are not in the phase you mentioned yet, because we dialogue every day with other competitors, with other businesses in the sector, and we are not experiencing yet an operational phase. I believe that before anything, we need to introduce this transition. In fact, as the colleague said, the introduction of AI is an enabler in order to switch to physical AI, but this first phase has not been completed yet. So this is a progressive evolution, a progressive transition. In our case too, our first phase was making processes digital and counting on a range of digital data in order to strengthen AI when applied to industrial processes. And this is the phase we are focusing on. The next step is introducing physical AI, for example, the collaboration between humans and humanoids. Well, physical AI is not the case yet. We are experimenting, we are still experiencing it from an industrial point of view. Two very telling examples are China and the US. Europe still lags behind, and in fact we should focus on Europe because we need to recover in this run. And we are starting to focus on that because we believe that the future lays there, for a luxury company and hence for Motor Valley, people will be crucial, will be always crucial. In the next years, people will not be replaced by humanoids. There are so many activities, so many tasks like logistics or ergonomics that do not add any value to the car, to the vehicle. And those activities, those tasks can be assigned, can be allocated to humanoids or to robots. But in the next few years, we don't forecast a replacement of human beings, of humans. So robots will not replace humans in the next few years in this area and in these plants. Leave now the floor to Mr. D'Aquino, and then I will come back to you to delve into what you have just said. Mr. D'Aquino, please, your standpoint is? Well, we need to differentiate what phase we are living in. There are two different forces when it comes to the push for physical AI, and these two forces are opening up a new era. They are launching a new era in which we have seen that AI has been and still is an informing tool, but actually physical AI should be a different element, an element of action. This is the first thing we need to bear in mind, and we need to be organized for that. The first force, the first driving force, which is creating this wave of tangible actions regarding AI is the multimodal models. I can interpret now inside the same model the consistency of language, the consistency of the context in which I operate. And the second driving force is that the manufacturing costs of humanoids and robots are going down, and we are witnessing a big reduction, 30 times reduction. And then there are also other driving forces. The most common one is regulations. So what happens if a robot makes a mistake and creates a damage and damages something or somebody? For example, before we have been talking about claims. So what happens if a robot creates a dramatic accident, a serious accident on the job? So this is the current situation. The next point regarding the adoption is not that we are concerned about the replacement of humans, robots will replace humans and so on. No, I would say that the main concern is that we are changing the setting of it. In fact, dealing with physical AI means that we need to define the operational model and the way I want a robot to be autonomous. We come from an era in which robotics was a deterministic subject. So I perfectly knew what I had to do, for example, rescheduling, reprogramming a robot if I had to adjust or to modify a production line. Today, everything is different. In fact, I need to define the way robots, I need to define the way robots must behave. This is the second element. And the next thing is that I need to embark upon a journey in which interaction between men and humanoids is also a transition and a transfer of knowledge towards the humanoids, from humans to humanoids. So algorithms and models are originated from a very high degree of data, but during the training there has been no specific context. And the third element in this transition is what we name the definition of human AI chemistry. So the alchemy, the chemistry between humans and machines. These are rather organization-related elements, but then they become functional when it comes to the technological functioning of our production, of our manufacturing. So if I start from the assumption that products are more and more personalized, there is a higher and higher degree of software inside products. So I need to make sure that factories must be digitalized, must have a digital steadiness and the balance between engineering and manufacturing. Then I need to define the operational model by which I interact with this high degree of technology, because otherwise this will just be experiments or isolated examples in some possible areas in which maybe I can have some advantages, but in some other areas I will not experience the same things. So AI must not be an element of industrial competitiveness. The last question for you is addressed to Mr. Nicoli, and I would like to go over a concept you mentioned before. Regarding physical AI, you have already answered. I would like to know from you, Mr. Nicoli, if you see some application fields that represent a priority. Maybe before we start to apply AI to the whole sector, we can apply it to some fields of the sector. And the second question for you is that these experiments and these practical applications are now gaining ground, are now progressing very quickly in China and in the US, but in Europe, we are still lagging behind. So what is our problem about? Is this a problem of legacy, or are you witnessing any other limit, any other problem in Europe? Well, in my opinion, in order to answer the second question, we would need a much longer time, maybe an entire conference. But I will try to be short and answer your question as far as my opinion is concerned. Coming back to the first question, I truly think that physical AI represents the future. And step by step, not only in our plans, but also in our daily life, we will be influenced and impacted by physical AI. Take, for instance, demographics, and physical AI will play a crucial role in this. I can forecast up until some years. I mean, I can do a forecast up to 3 or 5 years. This transition is now in experimentation phase. And this transition could be limited to areas in which there are repetitive tasks, maybe a little ergonomics task, for example, logistics, or activities in which precision, accuracy painting is crucial. So repetitive and very technical activities. At least in our business model, we believe that AI can be an added value. On the other hand, in those cases in which the human work is still fundamental, our men and women will be the protagonists for a long time. And the second question is a crucial thing. In fact, we are now dealing with some POC regarding artificial intelligence, and we could now use robots that are cheaper, but actually the main cost is not the hardware, it's the software. It's rather the software. These robots are Chinese or American. There are some European businesses that manufacture robots, and I think that this challenge must be undertaken in Europe. Europe must try and go to the pitch, because sometimes we say that robots is the referee and the others are playing the game. But actually, instead of regulating and regulating and stop, we should be part of the game. When it comes to cybersecurity, the humanoid robot has a camera, and that camera is inside the factory. This camera sends data across all over the world. We don't know where it sends data. So we will try to make sure that we will have in Europe some companies that can compete with the giant companies in China and in the US, which are more advanced than us at this moment. I think that this is an industrial policy thing, and I will conclude by saying that from a Motor Valley standpoint, this could be an interesting challenge for the Motor Valley. If we understand Motor Valley as an industrial area, as an industrial district, well, this district should evolve, bearing in mind the next future, bearing in mind the next challenges, and together with AI, software could be one of the main industrial challenges ahead of us. Well, I think that we can draw inspiration from this wish of yours. I would like to conclude by asking the other guest whether he thinks the same. At Capgemini, do you see any other element that should be considered in these next few challenges? Well, I see the things from the different standpoint of my colleague. From a European point of view, France is braver than the rest of the countries. We have a physical AI lab where we do experiments. We created a playing field in which we experiment with our customers. We are now seeing industrial applications in fields that are critical from the safety point of view, like nuclear power. These experiments are thrilling, but we need to work as a district. We need to collaborate. We need to create contaminations. We need to collaborate, and we need to remember that AI seems to be a technological challenge, but actually this is also a humanistic challenge, an unprecedented one, an unparalleled one. And the vocation of industrial districts, should be this one. We needed to create a common future for our companies, and this future has always been thought in terms of human. So we need to learn that these technologies are real opportunities if we really want to build the future. These are not only threats, these are not just concerns. Sometimes we are trivial when we say that AI will replace the work of humans. I would like to thank Mr. D'Aquino, Mr. Nicoli for the contribution. Thank you. Thank you for being with us in this session. We rapidly move to the last two round tables. We are now switching from factories to the tools and instruments that make factories possible. And we will analyze this from 4 different perspectives. From the perspective of those who would develop the simulation systems in the global industry, we will also talk to those people who take this autonomy out of the factory. Then we will talk to those who work with high-end engineering in the premium world and also in the defense sector. And also with these distinguished guests. I will now list them. Michele Latere, Transportation and Mobility Senior Manager at Dassault System. Luca Ferrari, Global Senior Manager at Robotic and Barefoot Technology at CNH. Mattia Violi, Advanced Engineer Manager at HPE Group. And Miro De Soricelli, CTO at Newton. Welcome, guys. Welcome.
So, Mr. Latere, is the pronunciation correct? Okay. So Dassault System collaborates with aerospace global industries and has followed the shift in these manufacturing models supported by software and engineering. So concerning the differentiation in the development between Europe and Asia, I would like to ask you what is changing in the world of digital twins, in the manufacturing world, And do you see any difference in the speed of the adoption in terms of these systems? Is it a relevant one, or is the problem going to be solved very rapidly? Can you hear me properly? Okay, so thank you very much for the invitation. As Dassault Systems, we have the pleasure and honor, and we love to work in different industrial sectors. We were born with the aerospace expertise, and now the automotive sector is our most important revenue source, but we also work in different industries. So we are speaking of a state-of-the-art of technology and innovation in terms of designing a mechanical object. That was the near past. But the present says that the new car should be very similar to a smartphone. But in effect, it is far more complicated because a smartphone does not have wheels, does not have to offer the same performances of a vehicles. And this is what we expect, that we achieve a mechanical performance, but associated to the SDV principles. In the automotive world, we have seen the sector chasing after the model-based system engineering. And so, the automotive sector is chasing a number of processes so as to enable software-defined vehicles. From this viewpoint, we have seen that startups, new realities that were originated in China. So Liam, Lucy, and Tesla have the disadvantage of having no legacy, no heritage, but defining new processes starting from a blank slate, a white sheet. And so they have been able to develop new engineering processes that offer the grounding systems that allowed software and hardware to be in dialogue. And we've seen Chinese realities to establish their processes going into this direction. Now, we are involved with all of these foreign realities and Chinese, European, and American ones. So as we want to, because we want to achieve this radical change in the development of products and in the processes of vehicle development. So this is a systemic approach that will allow us to design the SDV concept efficiently. And let me open brackets here and focus on the concept referring to data reliability, so as to get the link between hardware development, namely mechanical development, and software development. We should be able to uncouple these two topics rapidly, but they have to talk to each other. There should not be independent silos within the company. And the challenge, so, is to support the customers. We are involved by all the worldwide OEMs in terms of chasing the efficiency making of processes, of solutions that will implement data across the various departments so as to be deployed efficiently. And this is the first step towards virtual twins. So a virtual twin is the virtual representation of a physical object. And to achieve this consistently and coherently, all data have to be reliable, consistent. Mechanic departments have to use the data from the software department. And conversely, the software department and after sales department has to have all the correct data available. And last but not least, data enable AI. with the Pininfarina colleague yesterday, we were speaking of AI, artificial intelligence. Intelligence means if we are able to judge if a reply to a prompt is correct or not. We are now working with artificial statistics rather than intelligence. Everybody speaks of adopting AI, but industrially speaking, nobody is adopting it yet. Now, at Dassault Systèmes, we believe that the real value is to access AI based on corporate intelligence. So I will be able to have my data be accessible to AI so that my company will be able to grow. And here we enter another topic, data property, and to leverage the benefits offered by this technology. So we are really facing a revolution in terms of approach, system evolution, and development and deployment of systems that is the grounding force of the virtual twin adoption and AI within a company. Well, thank you very much, Michele. So it's not just a question of AI, but also of IP. Data property has to be protected as well. Now, Luca Ferrari. CNH, we have focused on automotive, a context that is regulated, roads, signage, etc., but you also play in the open field. So how are you approaching the SDV challenge? Is it a technological problem, or is it an issue in terms of adoption of the systems? Thank you for the invitation, first of all. And CNH is a case in New Holland acronym, so we operate off-road, so machinery for farming and building yard machinery. So SDV is a concrete and present reality. Our customers, namely farmers, have needs, and we have to meet their needs with these solutions. What are their needs? Well, they need time windows where certain operations may be performed are becoming shorter and shorter. They need to perform certain operations that previously had 4 weeks available. Now they have to perform them in 2 weeks' time. So they need more efficiency. They have a labor force problem, and this labor force is not skilled, and also an issue that is presented by sustainability, and our machinery is sustainable. We have presented an R4 robot. It is in Largo San Giorgio, close to Piazza Roma. It is an autonomous vehicle, and the next challenge is not just driving. We have to also perform operations on the open field. We have to be equipped with sensors, with AI operation driving systems that have to guide the vehicle itself. Technological innovation is very fast-paced, and we want to solve some of these challenges thanks to partners, startups, observatories, academia, and the Green on Brown Association that will allow us to detect weeds and apply the pesticides only where these weeds are present, and so we are more efficient, cost efficient, and more sustainable. We have performed this by collaborating initially with the investments, then acquiring a startup, Augmenta, and now this system is already factory fit. We are already manufacturing it. There are challenges, as you already said. We operate in an open field, and in manufacturing, we have environmental situations that change. Day and light operations, visibility that varies. Forage is normally collected when it's dry, so a lot of dust and powders that are present. So also adoption is a challenge. There are technological supports, sensors that are able to see, to make numerous conditions visible, algorithms that allow us to determine parameters, but to have a reliable system that works in any situation requires development times that are long. Now, to close, as already anticipated, and also as my colleague from Dassault Systèmes has said, we open in an environment that has seasons. We have to respect nature, and we may test our systems only 2 months in a year. And this, with simulators and virtual emulators, digital twins, is key because we can elaborate scenarios and use cases that are unfrequent, less frequent, so that in databases where our algorithms are trained is more uniform and represents the real use case. Now I'd like to give the floor to Mr. De Storicelli. He operates, he's the CEO of a startup in Newton. They are an accelerator for the Motor Valley with numerous partners, Cassa Depositi, Prestiti, Unicredit, etc. So you are collaborating with great players, but you are a startup. How can this be a great help in order to work in your sector? Well, being a startup, explain also what Newton deals with. Yes, when launching a startup, you have to have deep knowledge on a specific issue. In SDV, we offer a very important and critical solution. As has been repeatedly stated, the vehicle is a software-driven car or vehicle, but it is a mechanical object in the all in all, and so it has to work with the different operational environments. So in terms of temperature, of seasonalities, etc. And to work, the vehicle has to be able to detect where it is operating. There are some limits nowadays. Physical sensors do have limits, and often it's not possible to put physical measurement sensors where we have criticalities, where we need to be very accurate and know what is happening in real time and make decisions in a very, very short period of time. In powertrain electric motor, in 10 seconds in acceleration, temperatures moves from 10 degrees to 200 degrees. So the physical sensor should be on the coil in the last section of that process. But there are tolerances that will not allow the physical sensor to detect the right temperature, and the controller software should be based on this efficiency, and that's very difficult. So we believe that our value proposition will bridge the gap of the hardware issue thanks to software. We will collect all the data in the design time and the layout design, where we can accurately model physics, and we want to put it on the microcontroller, and we distill the numerical control, deploying the physics expertise that we have modeled in the last 200 years, supported by AI, because operating in a context where there is a high contaminations between stochastic components, variables, etc., without AI, we cannot exploit the physics of natural processes. So we embed in our systems smart intelligence, embedded intelligence on inverters, on electric motors, electric cars, electric vehicles. And we believe that our solution will unlock a technical constraint that the industry developed hardware, sophisticated hardware that it cannot control, and often 10% to 20% of performance is lost because we want to achieve safety and security, and we cannot leverage 100% of performance. So I believe that our startup will have a relevant role in order to solve these bottlenecks, and that will allow a platform to be there, will allow to be scalable. So we will oil and grease those rings that require more functionality and raise the bar at industrial level. Now, I will conclude with a provocation. We are based in Padua. We have been on the market for, we were launched 6 years ago, 3 years on the market. We have spoken of China, and we are now working more with the Chinese market that is far more aggressive, far more open to exploring technological innovations and testing out things that still need to be validated if compared to an American or a European player. Many thanks, Milo de Storicellis. Thank you for this provocation that really goes to the core of many problems. Now, one last question to close these four perspectives that we offered in our round table. So, Mattia Violi, HPE Group, moves in defense and moves in the automotive sector. So let me understand, how are you able to work in both industries, in both domains? How can this allow to facilitate the adoption of these different practices? And is this double exposure in a way changing what your customers are asking you to do? I would also like to thank you for the invitation as well. We were started 6 years ago with HPE with Gen AI. We were exposed to these topics in all of these sectors, aerospace, defense, automotive, and automotive is really leveraging all this because of dual uses. And we've seen a strong change. We work on complex mechatronic systems, which until some years ago were quite static. When developed, they were made operational, functional, and then this was reiterated over and over again in the system independently from the operational context. And now we are moving towards dynamic systems, adaptive systems, which are able to interpret the operational situation, the context, and present an adaptive controlling system, not on the open field. I should stress that with defined limits in development so as to guarantee safety and trust. Now, this challenge has opened us to hybrid systems. So if AI was cloud-driven, now we have hybrid-driven architectures because these require decision-making abilities. It is agentic AI, so these have to be always available on board, reliable, and should also operate without connectivity. This has taken us to design hardware and software together, not because they are dependent one on the other, but hardware has to deploy the content operatively, and they have to be scalable. Initially, we started from components, and then we've understood how to work and make this scalable on vehicles, on fleets, and in aerospace, for example, we are challenging autonomous satellites to be available so as to orchestrate, this is the word, constellations. All of these challenges have brought us to an important link between modeling, deterministic model-based virtual twins, and synthetic data together with on-field real data collected that will be onboarded on the vehicles. The fact that we will get a digital twin requires a reliable and trustful modeling of the system, the possibility of applying sensors to the system, and having hardware and software technologies in the loop so as to have virtual testing and physical testing in the lab, and then have a shorter time to market. So now the new frontier is not only that of physical AI, but physics AI, so accelerating the development of products with the automation of design and simulation during the development time. So we really shorten the time to market timing. So the four of you really shared a great perspective that would require a specific conference, but we do not have enough time to focus deeply on all of these topics. So thanks to the four of you for this presentation. So thank you.
And we are now about to draw the conclusion of this session with the last roundtable. This last roundtable regarding perspective and innovation in the SDV. We will now take a look at this scenario from a very broad perspective, which is embedded connection, design, so the whole supply chain is widely known all over the place, all over the world, and now this supply chain needs to deal with the radical complexity, a radical transformation. I would like to call on the stage Giuseppe Bonollo, President of Car Design Engineering at ANFIA, SDP Business Mobility Pininfarina, Ilario Gerlero, partner at Sensor Reply, Giuseppe Mercurio, Intelligent Mobility and Software Director at FEV, and Francesco Ricciardi, CEO at Biologics and Vice President at ANFIA. Thank you. Very well. Now, this very last round of questions in order to talk about an excellent supply chain in Italy, a very important supply chain for the whole country. I would like to start with the first question for Mr. Ponolo. You have been leading the current design department at ANFIA, so this mandate is the result of a very high structural pressure. I would like to start by using a data I used this morning from the European Association of Automotive Suppliers. According to this data, the 50% of European suppliers forecast that in the next 5 years the industrial capacity will be reduced, while only the 5% of these constructors think that they will expand the industrial capacity. So what about the Italian chain? How do you defend this heritage, this industrial heritage in Italy, when the rules of the game are changing so dramatically? Okay, this should be working. Yeah, everybody can hear me. The mic is perfectly working. Thank you. Thank you very much, and thanks for the question. Thanks for having me. I would like to go straight to the point, a very important one. But before I go straight to the point, I would like to spend a few words regarding ANFIA. If you do not know ANFIA, this is the National Association of the Car Sector Supply Chain, and it joins about 530 members in all the sectors of the car sector in Italy. So both constructors and accessories and components and spare parts, and engineering, which is the sector I represent. In this group, we have about 30 members. All the 530 businesses and the car design engineers have been growing in the past 5 years because the complexity of the industry is exponentially growing. So in this association, what we do is providing support to the members so that they can more easily dialogue with this growing complexity. Let's now focus on the topic of this panel, which is SDV, Software Design Vehicle, and all the implications and repercussions on the supply chain. The forward is that the Italian supply chain, as it is being shown at the Motorfest, has no reason why it should be worried because of this complexity, under two circumstances, under two conditions. The first condition is that we are aware of the fact that the regulatory framework is evolving and is changing. Data became crucial when it comes to driving vehicles, when it comes to vehicle safety and security, and when it comes to customizing services, and also when it comes to the government and the certification of all the processes. The importance of data can be summarized under the term of cybersecurity, a term we are quite used to here. Cybersecurity is a pre-requirement now, is a type approval parameter that needs to be certified. So the first topic the whole supply chain needs to be aware of is this matter of fact. This is a matter of fact we need to know for sure if we want to operate in the sector, if we want to be players in this game. What is happening in the supply chain? Actually, there are two main elements, virtuous element. The first element is that providers, suppliers of components are a diligent interlocutor, a digital counterpart of OEMs when it comes to interpret the regulatory framework. And the second actor, the second player is, the second element is that OEMs ask exactly these things to their suppliers. The second thing is that as far as AMFIA is concerned, not only regarding the SDV, but also regarding self-driving cars, AMFIA is a very important actor at the European Union when the European Union dictates the rules of the future, especially in past February, when the EU and the competent commission joined. A group of work was launched. The name is ECAVA, European Connected and Autonomous Vehicles Alliance. I would like to stress the term alliance in this name. And this group wants to promote a collaboration ecosystem between OEMs and suppliers. This group is divided in 4 groups dealing with AI and modeling, connected vehicles, autonomous driving, and hardware. AMFIA is represented in these groups with our ability to influence the future definition of the regulatory framework, and also the excellent businesses of the Italian supply chain are represented in this group, particularly competent businesses that can be summed up in this name: Marelli, Technocrat Group, and some others. What do I want to say in a nutshell? I would like to say that we have all the skills, the necessary skills to play a proactive role, not only when it comes to compliance and to the market needs, but also when it comes to orient and address the future legislations. A very recent news, the general director of this group is an Italian man, so thanks to this fact, we have a privileged visibility, but we still need to invest. We need to continue investing when it comes to the interpretation and the evolution of the regulatory framework, and when it comes to increase and favor the exchange of knowledge between OEMs and suppliers. Okay, thank you. I would now leave the floor to Mr. Guerrero from Sensor Reply. They create decisional sensors regarding that are embedded. Sorry. You have achieved so many things. You have included and you have embedded so many LLMs this year without any dependence from the cloud. So the question for you, Ilario, and you have 5 minutes time. You have 5 minutes to answer. What does it mean to have these capacities embedded in the vehicles? What kind of problems did you solve? Were these problems more difficult before, and what are the boundaries? Thanks for the chance, thanks for the opportunities, and thanks for the question. The goal of the company is exactly this one, this mission. We want to support OEMs in a transformation towards SDV, and we want to make sure that they can use decisional making systems with the support of AI. This means that we need to interpret different things. We needed to embed the physical aspect of the sector and also the model-based design, for example. So AI should not be disconnected from the physical world and functioning of the vehicle, because otherwise it would be just AI for AI's sake. The embedding is now law. The degree of embedding is very poor. And then we need to be talking about the efficiency in real time. The 58% of data that are moved to the cloud, that are usually moved to the cloud, are actually very often useless, not because they are not interesting from an analytic point of view. They are useless because they are not studied, they are not considered in the right moment and in the right place. And the right place is the vehicle, especially when it comes to diagnostics problems, handling, comfort of drivers. This is the reason why we support all this by embedding AI modules that are able to work in real time with computation and IT times that are very, very short, and also with very high capacities of the sensors, of the power unit. These devices can take the decisional making process on board the vehicle, thanks to the cloud as well. The third main point regarding this is the scalability, the fact that this can be scaled up. In the previous sessions, we have been talking about the ability of the software to scale and to learn. Well, these softwares must be able to manage the complexity of the CI/CD, of continuous embedding, continuous integration, and it needs to be able to be embedded, because not all the data that are used in the designing phase will represent the actual operational ranges of the vehicle. Putting together these things is what we do. Depending on the application, we may be talking about a sensor. In this case, we use techniques and methodologies of AI that are actually much simpler, machine learning and deep learning. And then, on the other hand, we have assistants that work in real time to support driving. In a multimodal way, these devices and these systems put together information regarding the environment, regarding the surroundings, regarding the driving behavior of the driver, and this is continuously evolving inside the same mission. For example, LLMs and multi-agent systems give us the chance to do this, to build assistants that work in real time. This allowed us to develop methodologies that, first of all, were applied to the automotive sector. And then, in the past 2.5 years, gave us the chance to evolve in the manufacturing sector, because by using the same methodology, by using the same philosophy, we were able to work in the software-defining manufacturing, SDV and SDM, so assistance on board the car. Before we mentioned the decoupling together with the colleague from Iveco, there is still a good room for growth, a good margin for growth. I would like to talk now to Giuseppe Mercurio from FEV. Your reputation has always been strong and widely known to everybody. You are sort of leaders in terms of traditional engineering, and now, very recently, you have launched, you have opened a new division, a new department. I don't know how to define it, maybe a new branch. The name of this branch is FEVIO. It is a brand dedicated to the mobility software. By this new branch, you want to explain the way value is shifting from one sector to another, from one segment to another. So, would you like to tell us, Giuseppe, what has changed in the way you dialogue with your customers? Because this is a new positioning for you inside FEV. You're now proposing new things to customers. So what customers ask you? What do customers ask you? Thanks, everybody. Thanks for having me. Emiliano, as you said, FEV has a very rooted history in the powertrain and in powertrain engineering services. In other words, many customers know our company thanks to powertrains. Inside our group, inside FEV, we have always had and developed electric and electronic competencies and skills, embedded systems, and very recently we felt a need to define and to create a specific division, a specific department on purpose. And the reason was that the development processes and the adopted methodologies are more special in this world, are more peculiar. So it goes without saying that they require a specific study, a specific attention. In this field, our group, FEVAO, is taking the chance, is taking this opportunity offered by AI. But as we said before, as other colleagues mentioned before, this has to be applied as a cascade with a very strong engineering approach. AI today is able to create requirements, to review requirements. It is able to generate data scales and softwares. But the problem never lies in the way we generate a software for an algorithm. The main problem has always been and still is that we need to make sure that requirements are very well interpreted and understood. We need to make sure that the system is solid, is firm in terms of security, data security and safety. From this point of view, we try to exploit and to use all the available technologies. Digital twin, for example, is one of these tools we have, and the goal of the digital twins is to increase the usability of the systems, not only by reducing the time to market, but also by enlarging the scale of the tasks, the tasks cases we can cover, or maybe by representing possible situations that are difficult to be reproduced in the reality, in the real world, or maybe that would be dangerous in the real world. Codes development through AI is another element, is another huge opportunity. In my opinion, this will be a paramount challenge in the next few years. And in this challenge, the role of engineers will change. It will not be replaced. We are okay with that. We know that for sure. But the way engineers work will be different. So the engineering value chain will be enlarged and it will pass to the next level, to the next dimension. There will be teams that will be more focused on system engineering, on modern systems engineering, as it was pointed out in our sessions. So this represents for sure a multiplier, a multiplying factor of acceleration, an accelerating factor of the capacities. But everything has to be applied and implemented in an ecosystem that knows how to embed the individual technologies in an organic way, in an orchestrated way, in a very organized way. This is the message we want to spread and we want to share with our customers. The challenges doesn't lie in the way we build a single technology, but rather in the way we create a robust system in order to guarantee safety and security and the robustness of all automotive systems. Thank you for anticipating a thing. Thank you for talking in advance of this thing, which is coding. In fact, I wanted to ask the same question to Francesco Ricciardi. Right 1 week ago, you were in Bologna to talk about software-defined vehicles, SDVs. With Biologic, you are specialized in what is known as connected mobility, connected systems. So there is a sector in which high coding will create codes autonomously. So we are witnessing a very quick evolution, a very fast evolution in the sector. The provocative question I have for you is a question that will help us close this session. Do you think that this positioning of yours is running a risk of disintermediation when it comes to these processes, or you think that this is the right positioning in order to rule on the sector, in order to govern change? Thank you for this paramount question, for this difficult question. In fact, I've always had my question in my mind since last week when I participated in the meeting in Bologna. I think this is the beginning of a new era. And in this new era, we will be witnessing different changes in product, for example. And the main change is the software design vehicle. We usually talk about software, but we cannot forget the hardware. While the software is getting used to continuous releases, something different happens in hardware. We can see that in our mobile phones, because our mobile phones are software designed. The release of an operational system happens maybe twice a year. The release of applications happens some other times, many more times per month. And the release of patches needed by the applications in order to manage many data can happen different times per week. And we are seeing these among our suppliers, among the services we use. Regarding AI, we are becoming used to new releases every week, releases of different and complex systems in order to develop applications, in order to answer emails, for example, LLMs. These systems are particularly robust from the regression point of view. Unparalleled systems, unparalleled robustness. So in this development, we are witnessing new mechanisms that we had never seen before, and this is profoundly impacting our job. Our job is reorganizing our companies. I cannot use AI as a tool to accelerate my voicemail, in order to accelerate my software accelerators. If I accelerate the whole system, humans become the bottleneck. So basically speaking, we as a company are trying to support our customers. For 20 years now, we have been working on the embedded systems. We have always tried to understand how to embed the systems. So it goes without saying that we are trying to help our customers absorb what we are releasing more and more quickly. So we need to take into account that we are switching from AI systems used to develop software-designed vehicles with a high degree of automation to systems that can be developed and can develop in an autonomous way. So if I have an AI system, an automated one, that manages to classify all my emails, but then at a certain stage, it asks me, what do I do with this email? Well, I become the bottleneck. So the next step is this one. I wouldn't say that we are addressing a change, reduction in the size of the companies. I do not believe in the one-man companies that can solve every problem, making billions and billions. We have competencies, we have skills, we are skilled persons, okay? And we must remember that in the industrial field, as far as automation is concerned, we must remember, I said, that we have a very important resource, which is data, and data are used to train AI. So actually, our role, our task will change from being data provider, data supplier, and instructions providers, I think that the most straightforward case is the automated robot that performs tasks at home. That robot has been trained by us, in fact, humanoids, for the home usage will be the most spread out robots, because in the industrial field we do not have so many data. So the main thing will be developing and reorganizing, rearranging companies, and also regarding in deployment, we know for sure that we needed to develop these things in a lean way, in an agile way. Remember, please remember that we are representatives of a business that is made of safety and security. So do not interpret, do not see our cars as mobile phones. Thank you, Mr. Ricciardi. Let's now talk to Ilario. Ilario was nodding with his head. Would you like to make a consideration or a remark in 1 minute? Okay, just 1 minute, because then we need to finish. I think that Francesco has mentioned everything, pretty everything. I cannot but agree with him. Value does not lay, in the way we do software development with the right cycles and with right rules. So it does not coincide with engineering rules, but rather in the opportunities given by these technologies in order to optimize the competencies of people in a different way, in order to make software safer, more robust, and more scalable. And this can be done by people, only by people. I would like to close this session now with the words of one of our panelists in order to have the view, in order to get the view of the whole chain, of the whole sector. Do we run the risk of being prisoners of definitions? In the energy transition with the Green Deal, we have become prisoners. I do not want these tags to become, to forget the market, to forget what is the market, what the market is, sorry. I love this term you used, tags. We cannot become tags. Francesco said that it is impossible to compare a car with a smartphone, with a mobile phone. In spite of all the growing acceleration we are having, we need to bear in mind that we work on two planes, on two dimensions. On one hand, enabling technologies, the level of artificial intelligence and software-defined vehicles, AI applied to SDVs and SDVs, but we cannot neglect the market. These tags are referred to the innovation in processes, but actually they have to do with the industry. And the last string of the chain must receive messages that bear in mind the whole sector, the whole industry. And Italy is a very rich country in terms of design and in terms of engineering. The group I represent here is Amphia, and the whole group includes excellent businesses that can express the creativity of this industry. Please remember that we already have these, and we can give these to the customers, to the market. Just a couple of seconds to recall that the time Green Deal became an ideology, and the ideology created the equation according to which the Green Deal brings us to buy electric cars. Well, in that time, the market collapsed because market actually needed a carbon neutral message, not an imposition, not a diktat. And what BCG showed yesterday is that the market nowadays is still playing at a pre-COVID level. Small cars are now rare. They necessarily needed to be cheap, so we needed to act. Bearing in mind that as industry representatives, we need to be powerful when we spread out messages. These different planes, these different levels must be differentiated. Thank you for these closing remarks. Actually, this remark would open up for further considerations. Thank you, Mr. Bonolo. Thank you, Mr. Mercuri. Thank you, Mr. Ricciardi. Thanks for sharing this session with us. And thanks to all of you for following. So the question for all of us is not only the how do we build, how do we construct, it is also how do we create value. This is an open question, and this is the topic the Motor Valley Festival is pretty focused on. Thank you.